Functions and relations. Determine the domains of functions or relations. The domain of a function is simply the set of inputs over which the function is defined. So if I have f of x equals 5x, here's my input, x. My output is the result of multiplying the inputs by 5. Well, since any real number could be multiplied by 5, all the real numbers are my values that make up my domain. So my domain would be negative infinity to infinity. And the moral of the story is the function's equation, if it has no denominator or no even root, well, go ahead and check to see if the domain could be all real numbers. Now, in our second case, we're going to take a look at where you do have denominators that have variables in them. And we know we can never divide by what? Never divide by?
Zero.
Zero. So when I ask for the domain of f of x equals 1 over x, I need to exclude 0. So the way I do this is I say to myself, gosh, if I have a number line, at 0, I would not include it, so I would have an open circle there. What this does is it creates two intervals. This first interval are all numbers smaller than 0. X is less than 0. So my domain would be negative infinity to 0, but to not include it, I would use a parenthesis. Okay? Now, on the other side of 0, I'm looking at this interval here. The x values would be
greater than 0.
Greater than 0. So it looks like my interval would be what? It would be?
Would be 0 to infinity.
0 to infinity. Very good. And again, I use parentheses to actually exclude the 0. Then in between the two intervals, I'll go ahead and use a union symbol like that. Now, when I take a look at my second function, notice in the denominator we have x minus 5. So one way to think about this is that if I take my denominator, write it down and set it equal to 0 and solve, and if I solve, I find x to be equal to 5, I just want to be very, very careful. My domain are all the real numbers except for 5. So x equals 5 is excluded, which means not included in the domain. To actually find the interval, though, or intervals that make up the domain, I'm going to do what I did a moment ago. I'm going to go ahead and draw a real number line and put an open circle at 5 to exclude the 5. And then I'm going to repeat my thought process. I'm going to say, for this particular interval, the x values are
less than 5.
Less than 5. So to write that in interval form, that would be negative infinity to
5.
5. And to exclude it, I would use a parenthesis. And then for what? For this particular interval, I'm looking at all x values that are greater than 5. So to write that as an interval, it would be what? It would be
5 to positive infinity.
Very good. And to exclude the 5, to not include it, I would use a parenthesis. And then in between the two intervals, I need one interval or the other. I use a union symbol. Very good. So the moral of this story is that when you have a denominator, check and see what values to exclude, and those are going to be the values that will force the denominator to be 0. In our last case, we're going to take a look at even roots. You see 3 functions. All of these functions have even roots. And with even roots, you want to make sure that the radicand, that piece that's under the radical, is always 0 or more. So x would always have to be greater than or equal to 0. So to write this as an interval, I would write what? I would write
0 to infinity.
Very good. Intervals are always written from smallest to largest. To include the 0, I would use a bracket, I would use a parenthesis.
A bracket.
A bracket, and the infinity symbol always gets what? Always gets?
Parenthesis.
So here is my domain for this particular function. For my next function, I want to go ahead and use the same technique. So I want to say to myself, my radicand always has to be 0 or more. So I'm going to write that. I'm going to write, instead of x is greater than or equal to 0, x minus 5 is greater than or equal to 0, and I'm just going to solve for x. Well, if I add a 5 to both sides, I find that x is what? X is?
Greater than or equal to 5.
Very good. And how do I write that as an interval?
You would write,
5
Good. To what?
to infinity?
Would I include the 5?
Yes.
And I would use what to include it?
A bracket?
Bracket, and the infinity symbol always gets a
Parenthesis.
parenthesis. Well, we have one more to look at here, and that is where we have h of x is the square root of 5 minus x. But we're going to use the same procedure. Our radicand always has to be what? Our 5 minus x has to be what? It has to be
greater than or equal to 0.
beautiful. And then we're just going to solve for x. So I'm going to subtract a 5 from both sides of the equation. And that doesn't change the direction of the inequality symbol. But when I divide by -1, I do change the direction of the inequality symbol.
Right.
So when I divide by -1, x is what? X is?
Less than or equal to 5.
Very good. How do I write this as an interval?
You would write from negative infinity to 5, including 5.
Beautiful. So I would use a
bracket.
bracket on that end. So when you have a function's equation that has an even root, you want to exclude values that would make the radicand less than 0. Thank you.